Hi there. For those of you who had a little bit of trouble setting up files for assignment 4, I wanted to make this video so that people could see what they could have done better. So here I'm going to demonstrate this on the tic-tac-toe data set. So the assumption coming into assignment 4 is that you have already divided your project data into a cross-validation set and a development set. So, and this set here that we have, the tic-tac-toe data set, it has fewer instances than you will have in your project data set. So I'm going to make a slightly smaller development set, but the process is the same. So, and again, the assumption is you will have done this already before coming into assignment 4, but I want to have the files set up to do that. So I'm going to use the stratified remove folds filter to divide this ARFF file first into a dev set and then into a cross-validation set. And this follows also the process that I showed in an earlier video about splitting ARF files. Okay, if you open up the stratified remove folds filter, it's set up for a 10-fold cross-validation, but I'm going to set that to 9. Since there are 958 instances, if I want a bit more than 100 in the dev set, then I'm going to divide it into 9 parts. And so it's set up here with invert selection to false. That means it's going to extract first the small version of the file, and it's on fold 1. Okay, so it's all set up and ready to go. And see, again, 958 instances in the full set. If I click on apply, now I see 107 instances. That's going to be my dev set. So now I'm going to go ahead and I'm going to save that to tic-tac-toe dev.arff, and that's going to be saved to my desktop. Now I'm going to undo, and I want to save now what will be my cross-validation set, so I'm going to go ahead and set this to true and click apply. And now 851 examples are going to be in my cross-validation set. Okay, good. So now I have my dev set and I have my cross-validation set. And what I want to do is now I'm coming into this as though I'm starting assignment 4 and I'm going to load that dev set. Not the dev set, but the CV set. Okay, now in the assignment, it said that what I should do is set up for a 5-fold cross-validation. So again, I'm going to use the stratified remove folds filter, but now I'm going to set the number of folds to 5. I'm still going to start out on fold 1. I'm going to set this to false because I'm going to do the test set first. Okay, so now notice 851 examples. That's how many we have in our CV set. And if I click apply, now I am going to get 171 examples for test set 1. So now I'm going to save that as tic-tac-toe test 1. And I'm going to check off that I've created that file on my list, and I'm going to undo. And now I'm going to create the training set for that. So I'm going to set this to true, still fold 1, still a 5-fold cross-validation. Now I'm going to click apply. And now you see 680 examples. That's how many I have in my training set for fold 1. Good. Okay, check off that I created that. And now I'm going to undo. Now I'm going to do that again for the second fold. So I'm just going to set this to 2. I'm going to set this to false. Now I'm going to click apply, and I've got that test set. So this is going to be test 2. I'm going to check that off of my list. I'm going to undo, and now I'm going to create the corresponding training set. Good. Now 681. Good. And so that is train 2. Now I'm going to undo. Okay. Now I've got train and test for 2 folds, and now I'm going to do the 3rd fold. So I set this fold to 3. I set invert selection to false. Good. I click apply. I've created my test set. Now I'm going to save that. That's going to be test 3. Going to check that off my list. Going to undo. Now I'm going to create the corresponding training set. And I'm going to save that. Good. Now I've got 3 folds done. I'm going to undo. Now I'm going to do fold 4. And now I'm going to do the training set for fold 4. And undo. Good. Now I just have to do fold 5. Set this to 5. Set this to false. Good. Apply and save. This is test 5. Good. Undo. And set this to true. Okay. Apply and save. And I have train 5. Good. All right. So now I've got my 5 train and test pairs for the cross-validation. And I've also got my dev set. Now if I go to the classify panel, and I've instructed you in the assignment to use naive Bayes. Okay, now I am going to do a cross-validation by hand to get the performance values that I'm going to use for the confidence interval. Now we know that we have, let's see, how many examples were there in the full file? I can load that full file again. Where is that? So that's however many are in my CV set altogether. If I load that, it says I have 851 in my CV set. So that's going to be N. But what is going to be F? Okay, so to get F, which is our performance value, what we want to do is run our cross-validation by hand. So we're going to start out with fold 1, and we're going to open the training set for fold 1 on the pre-process tab. Then we're going to go to the classify tab. We're going to load a supplied test set, and that is going to be the test for fold 1. Okay, we've got naive Bayes, we've got this set up, and we're going to run it. Okay, so, and I've said that we're going to do our confidence interval over the kappa. So you can see here the kappa for fold 1 is 0.27. Okay, and we're going to do this for each of our folds. We're doing a cross-validation by hand. So now I'm going to load the training set for fold 2. And now I'm going to load the supplied test set for fold 2. That's going to be test 2. Okay, and then if I run that experiment, again, the kappa is going to be pretty close. Now it's 0.21. Okay, now I'm going to do fold 3. So I'm going to open up on the pre-process tab, training set 3. And then on the classify tab, the supplied test set is going to be test set 3. Okay. And, ooh, well, this fold is slightly different. We have 0.38. Good. All right. And what about fold 4? I'm going to open up fold 4. That's train 4. come over here, load the test set for fold 4, test 4, and I'm going to run it, and I get kappa of 0.26. Good. And now on the preprocess tab, I'm going to do the final fold. That is train 5. And now I come over here and load the corresponding test set. Test 5. Okay. And run it. And 0.31 is our kappa. Okay, so now I have a kappa value for each of my 5 folds. And to get the overall kappa, I'm just going to average this, and that's going to be my F. And then I can go ahead and compute the confidence interval. And the math for that is going to be found in the answer key. I'm not going to work that out in real time, because now I'm going to show you what to do for the next step. Okay, so now we've done this cross-validation. We can compute our confidence interval. We know what our performance is, but now we're going to set up to do an error analysis. So whereas on each fold we trained on the training data per fold and tested on the testing data per fold, now what we're going to do is load our entire CV set, and we are going to test on our dev set. Okay, so we're still using naive Bayes, but we want to output the predictions. Okay, and now we're going to run it. Okay, so if we look, we can see our predictions. Good, because we're going to need this when we are doing our error analysis. Now, in the assignment, what I've told you is that you should have your data for the dev set in a CSV file, and you're going to copy the predictions into your CSV file. Now our CV set, oh, not the CV set, now the dev set is an R file. So we want to be able to turn that into a CSV file. So I am going to load the dev set now on the preprocess tab, and I'm going to save it as a CSV file. Good. Okay, so now I have that CSV file, and what I want is to make it so that I can have columns that are these actual and predicted values. So first, I'm going to save this as a text file. Save result buffer. I'm going to save it to my desktop. Can I get to my desktop? Desktop. And I am going to save this as output.txt. Okay, now that I have that, I am going to edit that using a text editor. So I'm going to find the text editor that I like to use, which is WordPad. And I'm going to open that text file, which is on my desktop. Here it is. Okay. So what I am going to do is scroll down to where these predictions are and delete everything up to that. And then I'm going to go underneath of it and delete everything underneath. And this is described in the assignment. And now I'm going to save it again as a text file. Okay. Now, what you can do is go to Excel and import it. So if I now open this, then it's going to import it. So let's see, so it's, I think fixed width is going to do what we want. Yep. Great. Okay, cool. So now we've got all these, we've got these columns. We've got the column for actual, we've got the column for predicted, and these other things we don't really need. Okay, and now what we want to do is open up the dev set. Okay, and what we want is to copy in our actual and predicted values. Okay, so now just as a sanity check, we want to make sure that the actual values are lined up, and they are indeed. Good. Okay, and this is predicted. Okay, we're almost there. So now what we want to do is sort by actual and predicted. That's actual. That's the actual class and the predicted class. Now if we sort, we've got the cells of our confusion matrix. So here we have everything that's actually negative but was predicted as positive. And then we have negative that was predicted as negative. So these ones are all errors. Oops. Yes. So I'm going to make that, let's just make that yellow. So these ones are all error ones. These ones are correct. These ones are correct, positive, positive. But if we go down, we've got a few that are positive, negative. Those are errors also, but it's a different kind of error. Okay, so now what we want to do for the error analysis is to try to explain why instances ended up in these error cells. What is it that's different about these instances than the ones that were correctly classified? And so that's the reasoning that you're going to be doing on your data. Now, we know that Naive Bayes was very poor at this task. So it's very likely, actually, that there isn't a lot that it was able to figure out. But we do know that position 5 was particularly telling. So frequently, what's going to happen is, so when the class is negative but it was predicted as positive, I bet it happens a lot when X is in position 5, because we know that position 5 is particularly strategic. And you'll see that in the cases where it was negative and it predicted negative, it actually was never the case that that there was an X in the middle. But there are cases where, well, so many cases positive, positive, where X was in the middle, but where it's positive but predicted as negative, most of the time it was not. There wasn't an X there. So we predict negative often when there isn't an X, and if there is an X, we're likely to predict positive even if it's not really positive. And what we should really be paying attention to are the other positions in the representation, but of course Naive Bayes is going to miss that. So that would be an observation that could be made about this data by comparing what we see in the cells that we know that the model is paying a lot of attention to, and the pattern of results. And that's the kind of reasoning I'd like you to be able to have engaged in assignment 4. But of course it was kind of tedious and tricky, and it's not giving you a whole lot of guidance. But I wanted you to see what is this task we call error analysis in its very difficult form, so that when we talk about it more in light side and it offers you more guidance, you'll understand the role of that guidance in your process. So we're going to continue to talk about error analysis from now on, and in assignment 6 that's going to be huge, and also on the practical part for midterm 1. But we sort of introduce these ideas layer by layer. So this assignment 4 helps you to get that set up.